We're going to have a look at another compound measure, this time density. To begin with, have a go at these unit conversions. Pause the video now and have a go, and when you're ready for the answers, press play. Okay, here are the answers. So to remind you, these should be our unit conversions. So times by 1,000 there as well. This is how we convert between milligrams, grams, kilograms and tons. You should have 26,000 milligrams, 0.5 grams, and then 2 meters is 200 centimeters. So 2 meters cubed is going to be 2 million centimeters cubed. Because 200 cubed, well, it's because of this actually. It's because if I want to go from centimeters and meters, if I want to change between these two, centimeters to meters, we would divide by 100. Meters to centimeters, you would times by 100. So if I want to go between centimeter cubed and meters cubed, we need to divide by 100 cubed and times by 100 cubed. 100 cubed is going to be 100 times 100 times 100, which is going to be 1 million. So if I want to change meters cubed to centimeters cubed, you need to times by 1 million. Density is quite commonly misunderstood. It's not just the amount of stuff inside an object, it's the amount of stuff inside an object compared to its volume. Think about what unit density is going to be measured in. The amount of stuff something has is its mass. And what can you measure mass in? For example, we could measure it in kilograms. What could we measure volume in? For example, meter cubed. So 1 unit of density would be kilograms per meters cubed. You might also have grams per centimeters cubed. Here are some examples of density. The density of water is 1,000 kilogram per meter cubed. This is the density of some forms of steel. And lastly, the density of a neutron star is 10 to the 17 kilograms per meters cubed. So I think that's the densest substance that we know. This is a formula triangle for working out density. We know that density is mass divided by volume. So if I want density, I can cover it up and I have mass over volume. If I want mass, I cover it up and I have volume times density. And if I want volume, I cover it up and I have mass divided by density. As long as you pay attention to the units, you shouldn't have any problems here. So if I look at the example, calculate the density of a stone of mass 350 grams and volume 45 centimeters cubed. I want density, so I'm going to cover it up. So I cover up density, and that is mass over volume. The mass is 350 and the volume is 45, but pay attention to the unit. It's 350 grams, 45 centimeters cubed. And we'll just work that out. And that gives us 7.78 or thereabouts. And the units are going to be grams per centimeters cubed. Here's another example. The density of aluminium is 2.7 grams per centimeters cubed, and we want to work out the volume of a block of aluminium that has a mass of 750 grams. So what we need to do here is cover up V. So we have volume is mass divided by density. The mass is 750 grams. The density is 2.7 grams per centimeters cubed. So I need to do 750 divided by 2.7. And I need to give my answer to 2 decimal places. So I have 277.78. And the units are going to be centimeters cubed because that's the unit of volume that I have in the question. Here's another question. Gold has a density of 19.3 grams per centimeters cubed. Calculate the mass of a gold bar with a volume of 30 centimeters cubed. So if I cover up M, I'm going to have volume times density. The volume is 30 centimeters cubed, and my density is 19.3 grams per centimeters cubed. So let's work that out. So we have 30 times 19.3, giving us 579, and the units are going to be grams. Here are some questions for you to try. Please pause the video now and have a go, and when you're ready for the answers, press play. Okay, let's go through the answers. So for the first question, we want the density. So density is mass over volume. So the mass is 780 grams and the volume is 84 centimeters cubed. So if I work that out, we should have 780, 84. We should end up with 9 point, well, I want it to two significant figures, so it should end up to be 9.3 grams per centimeters cubed. The density of a 3 centimeter cube block of copper of mass 26.7. So for this, the density is going to be 26.7 grams over 3 centimeters cubed, which gives me 8.9 grams per centimeters cubed. Now that's a constant value now for copper. What would be the mass of a 17 centimeter cube block of copper? Well, mass is density times volume. Density is still 8.9 and the volume is 17 centimeters cubed. So I end up with 151.3 grams. Gold has a density of 19.3 grams per centimeters cubed, and I want the mass of a gold bar volume 1000 centimeter cubed. So mass is equal to volume times, or density times volume. So we have 19.3 times by 1000, so obviously 19,300. So I have 19,300 grams. To change that into kilograms, we divide by 1000, which gives me 19.3 kilograms. In question 4, we want to work out the mass of the block in grams and kilograms. Firstly, we need to work out the volume of the block, and that's going to be length times width times height, because it's a cuboid. So 4 times 3 times 8, which is 96 centimeters cubed. Mass is volume times density. So the mass is going to be 96 times 7.85, and that's going to be in grams. So we have 753.6 grams, which is in kilograms 0.7536 kilograms. Lastly, a block of metal has a volume 64,000 centimeter cubed and a mass of 2.6 million grams. Find the density of the block in kilograms per meters cubed. So what I'm going to do is convert the units. So first of all, volume is 64,000 centimeters cubed. Now to go from centimeters to meters, we have to divide by 100. So to go from centimeter cubed to meters cubed, we divide by 100 cubed, which is just a million. So we need to change 64,000 centimeters cubed into meters cubed, we need to divide it by a million, which will move the decimal point back 6 places, giving me 0.064 meters cubed. Right, 1, 2, 3, 4, 5, 6, 0.064 meters cubed. And the mass, I want the mass in kilograms. The mass, if I divide this by 1,000, 1, 2, 3, I get 260 kilograms, sorry. So the density is equal to 260 kilograms over 0.064 meters cubed. And if we work that out, we should get 0.64. We should end up with 4,062.5 kilograms per meters cubed.